let's look at transformations a bit, and different coordinate frames and things like that. And after that, I'll do a simple example of how to read information to MATLAB in real time, right? So it's basically covering this part of the problem, basically how to get information from a robot into MATLAB. Okay, so to do that, I'm actually going to use the fetch robot as an example. So if I start the fetch robot simulation, so I started the fetch robot simulation in Gazebo, right? And I'm also going to say add an object in front of it so we can look at the camera image of that object. Let me add some color to it. Yeah, I think might be different settings and things like that, so maybe have a look. Let me change some colors here. Cool, so we have like a red block now. Oops. I don't know why I closed. It's kind of close the model editor. Right, so we have a red cube here. Right, cool. So let's and then we have the fetch robot, right? And the fetch has some cameras in front of it, right? So the first thing you need to do is let's look at what sort of information we're getting from the fetch, right? So if I type in lost topic list, I get all these different topics that the robot is publishing, right? So just to connect it with what I was talking about here, we have our robot, and the topics are basically all this information the robot is publishing, so that you can subscribe to that information and listen to the sensor information, as well as some of the topics will be control related, right? So for example, you would have you can see here information about the gripper joint positions, right? So topics like that, you can publish information back, right? So that you can control, say, the gripper arm and things like that, right? So there are some topics in here that will be sensor information that you can extract coming from the cameras, right? And if there's a LiDAR, it will be coming from the LiDAR. And then there are some topics in here that have to do with controlling the robot, right? So one aspect of setting up the simulation, you look at what sort of topics the robot is publishing, and then select the topics that you want to subscribe to, the topics that you want to listen to if you want to get information out of the robot, and then look at the topics you want to you want to publish back to when you want to control the robot, right? So try and identify them out of this list, right? So let's just look at the camera image, right? So obviously head camera RGB image raw should be camera image, right? So if I type in ROS topic echo and give the name of the topic, you see this is the camera information coming from it, right? And then I told you about image view, right? I type in image view. Image view. Okay, sorry, you should use RQT image view. There we go. And then if I choose this, you can see I'm seeing the cube, right? So if I look at this and I, for example, move the cube, you can see that this is the camera image, right? And the cube is moving, right? So this is what the robot is seeing right now, right? And this is the reason we're using a simulation, and you can't really do this kind of thing in RViz, right? So if I run RViz, for example, so in RViz I can visualize what the robot is seeing. So for example, if I put out the image topic, yeah, there we go. So here in RViz I can visualize the camera image, right? But for example, these objects and stuff, I can't move them around here in RViz, right? But RViz can help you visualize the data. Okay, so now we know that this topic that I just visualized was the topic. Head camera RGB image raw contains the camera image that you're gaining from Gazebo, right? So if this was a real robot, right, everything that I just did now would be the same, right? For example, if I took image view and I looked at this topic, instead of the simulated world, I'd have real images, right? So that's what I mean by from ROS's perspective, it doesn't matter whether it's real hardware or simulation, right? The topic that it's publishing will give you similar, like it will just give you a camera image, right? So this is it's a camera image of a simulated object, right? That it's seeing. So for example, this ROS topic list here would be pretty much the same if you had a real robot. Okay, so now you know which topic to look at if you want to get the camera image. The topic is basically this, right? Head camera RGB image raw. That should give you the camera image. So let's look at how we can kind of get it onto MATLAB. So if I launch MATLAB, okay, so to actually subscribe to a topic, you need to write a subscriber, right? So so if you just Google MATLAB ROS subscriber, you get an example of how to write it and everything, right? So it's simple. It's just a couple of lines of code, right? So let's just you need to start with something called ROS init, which is basically creating a ROS master in MATLAB. So So let's just quickly put together this code based off this, right? And we'll try to read this camera image in MATLAB in real time, right? So for example, while it's changing in MATLAB, changing in the simulation, that information will be updating here in real time in MATLAB, right? So ROS init connects to a ROS master, and then we need to create a subscriber. Let's just test. So you create a subscriber, and you need to mention which topic you want to read, right? So what's the topic we want to read? We want head camera RGB image RAW. So by the way, you can test this by playing a ROS bag as well, right? So while the ROS bag is playing, you can connect to ROS and try to read the information coming from a ROS bag in real time. Now you have to, I hope it's clear to you that in previous examples in the tutorials, what we did with ROS bags is not that we read the ROS bag in real time, we loaded the ROS bag onto MATLAB offline, right? So we kind of, instead of playing it in real time and accessing the information in real time, we loaded it onto MATLAB, the whole ROS bag in its entirety, and then we access the information inside of it. That's different to running the ROS bag, playing the ROS bag in real time, and then accessing the information. I hope that difference is clear, right? So I've subscribed using this line, and then to actually receive the message, I use receive, which is basically once you have a subscriber, if you receive information, it will be stored into this variable called message, right? And if you want to look at, so if you just run this, hold on, I need to, so now it's read the image, right? It's read this message, and I have this variable called message2. So if I looked at this variable message2, you can see that it's received image, and it's a 480 by 640 image, and it has all this information, the header, the width, and the actual data which is in here, right? So if you remember, if you want to actually visualize this image, you have to, so right now this is where all the data, image data is, right? So if you actually open this up, you can see this is all the image data, but it's not in the MATLAB matrix form that we can actually visualize it. So we have to convert it from a ROS image type to a MATLAB image type, right? So you can use this function called read image. So this is the same function we use when we were reading information from a ROS bag, right? And now I'm converting this message2 into a MATLAB image type, and now I can use, say, IMShow. And if I run this, sorry, I need to run ROS shutdown to start it again. Yes, it's already started. See, now I'm kind of getting the same image in MATLAB, right? So I've done this now in a couple of steps, but if you want it to continue over and over and over, what you would do is you would create an infinite loop, right? So you would create a while loop and say give it a infinite condition, like while 1 is greater than 0, right? So now it will continuously do this, right, and update it without exiting, right? So so let me put semicolons here. So now it's continuously updating, right? So for example, now I have the IMShow image here. Now in Gazebo, if I move this, you can see in MATLAB the image is changing, right? Because I'm continuously updating the information, right? So you can see it's very easy to connect ROS and MATLAB, right? So this is basically the same structure you'll be using to subscribe to any information. You write this line, receive the message, and whenever the message is received, it will be stored in this variable, and you can open that variable to kind of understand what sort of data is in it. And if you want to, you can visualize it using IMShow. So this is an example of camera information. It's the same if you had a laser, right? So if you had a laser, you'd subscribe to the laser information and then receive that information, and then you can do whatever you want with that information, right? And again, for example, like if you want to speed up everything, you don't even need to visualize it. So visualizing it is for your benefit, right? You can remove that, and you know that the data is in this variable called img, right? If you open it, I'll actually stop this. If you open the variable img, okay, so it says here that there are more than 524,000 images, so you can actually see it, but it will be a grid, right? So you can see here the structure of it. It's a 480 by 640 by 3 matrix, which is the image format that we are used to seeing. So you can just Google like ROS and MATLAB, and you will get where is that? Yeah, you'll get information how to write a subscriber. And let's say, so that's an example of subscribing to information. Let's say you want to control this robot and you want it to move forward. What you would do is you have to figure out which topic you need to publish to move it forward, right? Sometimes you might need another package to help it do that. And then just like you wrote this subscriber, you can write a publisher that will move it forward. So that's a simple example of how you can do that. Now I'd like to finish up by also talking about something very, very important, that is the transformations, right? So I've been talking a lot about transformations, and we've already dealt with the transformation chains inside a camera, right? But in a complicated robot like this, right, there's multiple coordinate frames. There's a coordinate frame associated with the base, and then for the head, and then the camera, and things like that. So if you want to visualize these transformations, right, you can type in ROS run TF3, sorry, RQT TF3, and it will tell you all the transformations associated with it, right? So you'll have a base link to which everything is attached to, right? You have a camera, hold on, let me close MATLAB before my computer crashes. There's just too many things running right now, right? So all the different coordinate frames that you have to deal with, you can visualize it using this TF3 command, right? So you can see, for example, where the camera is associated with the rest of the robot, and you can even visualize it in RViz, right? So if you launch RViz, you can add the transformations, right? So in ROS you can call them TF for short. So you can add the transformations, and here you can see there's this option called fixed frame. So the fixed frame is basically how you want to visualize, like with which reference frame do you want to visualize everything with respect to, right? So if I choose base link, you can see these are all the links associated with the robot, right? I think something small has gone wrong. Let me start this simulation again. I'll just use the teleop command and show you what happens when you move. So it's actually ROS bridge that I was using here, right? So when I was showing you how to connect MATLAB and ROS, what I was using is ROS bridge. So ROS bridge is kind of built into the MATLAB robotics toolbox. Hold on. So if I launch the teleop function, I can control the robot using my keyboard. And I'll just show you how the different transformations kind of play with each other. Right? So we have the robot again, and if I install it real quick. So if I now launch this, I can control the robot using my keyboard. Right? Yeah, so I'm moving the robot now, right? And now if I look at RViz, and if I select the base link, and I add the transformation tree, right? And if I move the robot now, right? You can see the robot is moving in Gazebo, but it's not moving in RViz, right? Why is that? Because the frame that I'm looking at, the fixed frame that I'm looking from, is the base link of the robot, right? So the base link of the robot is somewhere here, right? So if I'm looking at the movement from the base link, right, it's not going to move, right? Because my fixed frame, my reference frame, is the base link. So the robot is not moving relative to the base link. It's moving relative to the world, right? So I'll have to change my fixed frame to some sort of external frame so right now there is no external frame here, but you need what's that? Let me start a different simulation. Yeah, I think you need to launch the fetch navigation package as well, I think, to visualize its odometry messages, but you get the idea, right? So in RViz, you can visualize those different transformation trees, and this fixed frame over here is basically which reference frame are you looking at to identify the movement and things like that, and you can change that to any of the available frames in the robot. So if you pick a frame that is in the robot itself, obviously the robot's not going to move, but if you pick a frame that's outside, like the odometry frame or a map frame or something like that, you can see the robot kind of move in the world, right? Okay, so I'm going to wrap up there because it's 3 o'clock, but we'll continue this discussion as we go along. But yeah, understanding the different transformation trees and the different coordinate axes that are there is important, and you can actually visualize all the the transformations here. For some reason my transformations are seem a bit screwed up for some reason, and I don't see the camera transformations here, but I think that's some sort of small problem in my setup of the fetch robot. Yeah, because I should get the camera frames and everything up here as well. I'll figure that out, and we'll continue this discussion next week, but just remember the TF is a very important thing, because it will show you all the different coordinate frames in action. And for example, if you're getting images from a camera, it will be coming to the camera coordinate frame, and then you'll have to kind of transform it from the camera coordinate frame to the base link, right? So everything about ROS transformations can be found if you just Google ROS TF, right? And here in the wiki page, it will give you the tutorials, and I think if you do the introductory tutorials as well. There will be a section for introducing you to this concept of transformations, right? And the thing is, you can listen to those transformations and you can get those transformations. For example, if you want to figure out where the arm is relative to the base of the robot, you can kind of subscribe to that transformation tree that I showed you and get that information. Right? So all of that stuff is here in the tutorials, and if you need more help, we can keep discussing them further. So here is an example of transformations. It tells you what they do and why we use them. There's a whole bunch of tutorials, so you can listen to those transformations and you can broadcast transformations yourself, like subscribers and publishers. So I just wanted to mention that because it might be useful in your projects. Okay, so let's wrap up there. I hope this session was useful. I'll upload these videos by the end of today.